Hello and welcome back to the Maths Behind the Economics YouTube channel. This is video 4 in the Logarithms for Economics series, and today we're going to look at numbers as logs. So what we're going to talk about is what do numbers look like in disguise. We will also talk about where we cannot replace a log expression with a number, and as always I'm going to show you plenty of examples. Let's get started. If I show you log base 3 9, what do you think this is? Well, in my experience, for some of the students, as soon as they see the log expression, they straight away think, I don't know, this is a log expression. Why would I know? Well, remember, log is just another way of thinking about exponent. So, what log 39 is, what power do I need to raise 3 so that my answer is going to be 9? Well, in this case, I can work it out. So I know that 3 squared is equal to 9, so the whole log expression must be equal to 2. So log 39 is nothing else but 2 in disguise. 2 disguised as a logarithmic expression. Now, can we spot numbers in disguise in other cases? Well, let's look at log 15. Now, depending on the context, you need to be very clear about what base this is. Let us be thorough and play both cases. Let's assume for the first case that this is base 10, and then we look at how things change if it's going to be the other case when it's base e. So if it was base 10, then the question is, what power do I need to raise 10 so that the answer is 15? Now, 15 is not an exact power of 10, so it's not a power of 1, 2 or another whole number. So I need to enlist again the help of the calculator. So in this case, I need to pick up the calculator, put in log base 10, and then calculate what log base 10 15 is equal to. In this case, I could replace log base 15 with the number of 1.1761 rounded to 4 decimal places. I could have rounded to 2 decimal places. If I was to round to 2 decimal places, this would be just 1.18. Now, what happens if it's base e? Well, the question would slightly change because then I would need to look at what power do I need to raise e to so that the answer is going to be 15. Again, remember from the previous video, which I'm going to link you, e is a number which is 2.7183 to 4 decimal places. So again, the base is a number that we can represent as a finite decimal number, and I'm raising it to some power which is an exact decimal number. So obviously this is going to be again one of those cases when we're gonna have to round. So what is log 15 if it's base e? Again, use the calculator, not forgetting that in many scientific calculator the e-based logarithm is ln. So it would be like ln 15, and that is equal to 2.7081, again for 4 decimal places. But if I was to round it to just 2 decimal places, this would be 2.71 to 2 decimal places. What happens if I was asked the question, what is ln 5? Well, here it's clear what the base is, but again, the question would be, what power do I need to raise e so that the answer is equal to 5? Well, e itself is 2.7 something, so the exponent is not going to be a whole number like 2 or 3 or something else, because 2.7, which is almost 3, if I raise that squared, that's going to be over 5. So again, I need to use the calculator. Again, use the button of ln, type in 5, and don't forget to close the bracket if your calculator needs it. Hit equal, and then the answer is 1.6094 to 4 decimal places. Next question. What is log base 10 50 equal to? Again, what power do I need to raise 10 to so that I get the answer of 50? And I'm going to erase the question mark here, so we are being consistent with all the other answers. So 10 to raise 2 powers equal to 50. Again, our answer here for the exponent is not going to be an exact number because 10 to the first is 1. 10 squared is already 100, so we should expect an answer somewhere between 1 and 2. So again, enlist the help of the calculator. So we need to use the 10 base log, and we need to put 50 behind the log sign and not forgetting to close the bracket. So the answer here would be 1.69897 and a few zeros and a 4. Now we want to round to 4 decimal places. So we want to look at the 5th decimal place, which is 7. That tells me that I need to round the 4th decimal place up by 1. But what's further up by 9 is 10. So in this case, the answer will be 1.6990, because you can sort of think about it as 89 being rounded up by 1 to 90. Okay, so this is nice and lovely. We have seen a few examples when we can replace the log expression by a number. So what is common in here? Well, the common theme is here is that I know both the base and the argument in each cases, even though nothing is written here behind the log sign when I was looking at log 15, but I should know from either the context, that is base 10, because I'm looking at a mathematics textbook, or I know that is base E because I'm looking at an economics textbook. So either way, I will be able to calculate log 15. ln 5. Well, ln itself tells me that this is base E. So again, I know the base, but on top of that, I also know the argument. What's the number behind the log? And the last example, same. I know the base and I know the argument. The argument is an exact number and the base is an exact number. Right. So let's look at some examples, and I'm going to make a bit more space where we cannot replace the log with a number. So for example, logx. Well, I do not know this value. Why? Remember, log is an exponent. So what power do I need to raise 10 to so that it will be equal to x? Or what power do I need to raise e to so that the answer will be x? So again, we have got two cases depending on whether we're talking about log as base 10 or log as base e. But in either case, I do not know the argument. The argument is x, an unknown. So in this case, I have to treat the whole expression as an unknown expression. Another example. I've got ln a. Again, I don't know this value. I cannot replace this with a number. This is not a number in disguise. I have to raise e to some power, so that would be equal to a. Again, this is an unknown quantity because I don't know the value of a. Therefore, the ln a is also an unknown quantity together. Bit more space. And I've got log b of 5. What is this equal to? Now, I know the argument, but I'm not much further with that knowledge because now I don't know the base. So there's an unknown base that I would need to raise to some power, so that is equal to 5. Well, it could be so many different variations. Is this base 2? Is this base 7? Is this base 15? Is this base E? Is this base 10? You get the picture. So if I don't know either of the argument or the base, I cannot replace the logarithmic expression with an exact number. Now let's do some practice questions. And I'm going to make a bit more space. And then let us start with ln of 7. Well, ln is base E, so I know the base and I know the argument. So I should be able to calculate the value of this logarithmic expression. Again, I will need to use the calculator. Pick up the calculator, press the ln button on your calculator, followed by 7, close the bracket, and hit equal. So the calculator answer, and that's going to be a rounded answer, so you can put this little squiggly line on top of the equation sign, is going to be 1.945 and 9, because the next digit is 1 and we're rounding 1 down. So again, this is to 4 decimal places. If I was to round it to 2 decimal places, this would be 1.95, because the 5 in here is the deciding digit, and because that is 5 or more, I have to add 1 extra to the digit before, which is originally 4, so now that becomes 5. So this is the answer to 2 decimal places. Next one, log 10. What is that equal to? Well, it's either equal to 1, because 10 raised to the first is going to be equal to 10, or if we assume that log is e-based logarithm, so if this would be ln of 10, then again we just have to pick up the calculator. ln, then put 10, close the bracket, equal to, in this case, 2.3026. Again, I'm rounding to 4 decimal places, so don't forget the squiggly line. And again, I could write it to 2 decimal places, and that would be 2.30 to 2 decimal places. Now you might have spotted that I have used a double equation line with a squiggly line, as well as a squiggly line and just one straight line underneath. Well, both of these are commonly used. Each of them signals that from here on it's not an exact answer, it's an estimated answer. This is a rounded answer. Next question, log 5, 2. And again, I know the base, I know the argument, so I can calculate the value, but I will need a calculator because 2 is not a whole number power of 5. So pick up the calculator, press the log button, state that the base is 5, and then put 2 into the argument, and not forgetting to close the bracket if it's not already closed for you. And again, our rounded answer will be 0.4307, again to 4 decimal places. A bit more space again. I've got log2 0.25. Well, I know the base, I know the argument, therefore I can calculate the log value all together and find out what number is hiding behind this expression. You can just put this whole thing into the calculator and you can calculate it. However, I'd like to show you a little trick. I know that 0.25 is actually 1/4, and I know that 1/4 is 2 to the negative 2. Therefore, I can replace log base 2 0.25 by negative 2. And for these cases, I would encourage you to check it with the calculator to make sure that you definitely haven't made a mistake if you are not familiar with these calculations just yet. Let's look at one last example. That's going to be log base 3 15. Same scenario. I know the base, I know the argument, but I can deduce that the argument is not an exact whole number power of the base. Therefore, I need to use the calculator. So pick up the calculator, put in base 3, then type 15 into the argument and close the bracket. The answer here will be 2.464973 and so on. So again, this is just an estimated answer. However, we are in a similar situation than a couple of numbers ago. We want to round to 4 decimal places, so the 5th decimal places will decide whether we're rounding up or down. But here, the 4th digit is 9. So to round up from 9, I need to round up to 10. But that means I'm going to have to add an extra to here as well. So practically, what I'm doing is rounding 49 to 50. So the actual answer to 4 decimal places will be 2.4650. Well, I hope you enjoyed today's lesson. I hope you learned something new, and I hope that next time when you see a logarithmic expression where the base and the argument both known, you recognize this is nothing else, it's just a number in disguise. Thank you for watching. See you in the next video when we're going to talk about some special logarithms, especially when the logarithms have got the same base and the argument and when the argument is 1. And what does it mean? Bye!